Welcome you to another lecture in the series of discrete mathematics, right? So in this lecture I am going to discuss the paper which is of 2021, February 2021, and so we'll start with the first question, and some questions we have already done in the other previous videos. So I will skip those type of questions. Like this is your February 2021 question paper of discrete mathematics, right? Okay, so let us start with the first question. The first question is based on your right truth tables of conjunction and disjunction. So the first question is your that you have to show that these two statements, which is P and Q and R, right, and this P or R and P and Q, these both are equivalents, right? Are equivalent. Okay, so we have to prove that. So to prove that we have to make a truth table, right? So let's make a truth table for that. So these are the three variables, right? So in three variables that will be 8 combinations, right? Because three variables will have 2 raised to power 3, have the 8 combinations of true, false and false, right? So let me write this like that: true, false, false, false. Because I already told you this, but I remind you in this question because these type of questions are asked more in your exams, right? That let 0 0 0, right? Because 0 denote the false and 1 denote the right. So 0 0 1. If you don't need to remember this false and true, but what you have to remember that this series 0 0 0 0 0 1, and then it was 0 1 0, right? Then 0 1 1, then 1 0 0, right? 1 0 1 1 1 0. Okay, then we have this 1 1 1, right? Now fill F for 0 or false and 1 for true, right? 1 for true. So 1 for true. So here in this case we have F and T, right? Then we have F T F, right? Then we have F T T. Then we have T F F. Remember the 0 is for F and 1 4 is true, right? So true true F, and then we have this true true true. Okay, now find this one, right? P and Q. P and Q. Let me remove this or rub this from here. Okay, so I can get some space. So P and Q, right? So for P and Q, these two columns, we can say like columns, will be considered. So this is your conjunction, and conjunction says when both the statements are true, that it will be true, otherwise it will be false, right? So false will be false, false again will be false true again will be false, and this one will be false true false will be false, true false again false, true, 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 and true, true, true. Okay, and then P and Q and R. Okay, R. So here we have to consider these two, right? So false, 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 false true is again false, false, false again false, false true again false, 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 true, false, 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 true, false, and then true, true is true. So this is your truth table for that, right? Now find for P or R and for P and Q, and then finally for this statement P or R and P and Q, right? Okay, now see, P or R, P is this, R is this, right? So P or R, this is false, because this is your disjunction, and in disjunction, if one of the statement of if one of the variable is true, then the whole statement or whole thing is true, right? So here we have false and false, it will be false. Then we have false, true, that will be true, right? Then again we have false, false, right? False, 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 right? False, true will be true, right? True, false will be true, true, true will be true, and then we have true, false is true, and then we have true, true, true. So this is your P or R, and then we have to find P or Q, right? Oh, sorry, P and Q. So for P and Q we have already written this, right? P for P and Q. So we did not to again write it, but just for this, because we have to evaluate this statement based on these two tables, we can write as well, but you can leave it. But I am copying here again this false, 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 false. Okay, true, true. Otherwise, all is false. True. Okay. Now, because it will be easy for me to see from these two tables, okay, P or R and P and Q. So P or R and P and Q, and then we have to take disjunction of these two, right? Then FF, right? FF is F, because in this in conjunction, when both the statement are true, then the whole statement is true. Otherwise, it will be false. So here we have false, 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 true, true. So you can see that because using the truth table, we can see that these two are the equal, right? These two are equal, so that's why we can say that P and Q and R and P or R and P and Q are the same. All right. Okay. Let's move to the another question. This question says that B part, right? Prove that using mathematical induction, that 1 plus 2 plus 3 up to n is your n plus 1 by 2. So we have already did that type of questions, right? In which we have the similar questions in my first and second videos, in which I have discussed the 2011 previous year paper, right? So you can watch it, right? So I leave it to you to solve this and to learn it from that particular video, right? Okay, now the C part, right? The C part is prove that if A, okay, capital A, right? If A is set, right? If A is set with n elements, right? With n elements, then says P of A, right? P of A is your 2 raised to power n. So you have to prove that. Okay, let me write here, right? P of A is your 2 raised to power n. So here P denotes the power set, right? Power set. It means that the power set of a given set, right? This is the power set of A, right? Power set of A. You can read this, and this is your number. Means it says that the number of elements, right? Number of elements in power set of A is 2 raised to power. This is what you have to prove, right? So as we know that what is the definition of power set? First of all, we must know the definition for the power set, right? So what is the power set? So power set is your, right? Power set is, if for example I take this for you, that this is your set 1, 2 and 3, right? Then the power set of A will be null, right? 1, 2 means the set of individual elements, right? And then the whole, which is 1, 2, 3. This is the whole set. Means you can write it like 5, 1, 2, 3 and A, because we have taken A 1, 2, 3, so I can replace 1, 2, 3 with A. So that means I'm telling the definition of power set, and I will prove it in a second, right? So power set of a set, let's say A, is the set of all subsets, right? All subsets of A, right? All subsets of A. It means including the set itself and null, right? This is represented as 5, right? 5. So this is the definition of power set. If you don't know the definition, I have just written it for you, right? And now come to the proof, right? Now come to the proof. Okay, the proof says proof, right? Proof. So we can prove it right like that. X has an n element, right? X has an n elements, right? The induction hypothesis, right? Induction hypothesis. Hypothesis, you know what is hypothesis, right? We just assume something that tells us that the power set of X and the number of on this power set is your 2 raised to power n, right? Okay, and this is you have to now you have to prove about this, right? So let's say we have already seen that when we have this number x is equal to 1, 2, 3, then the number of elements in this power set has number of elements in the power set of x was 2 raised to power 3, means 2 raised to power 3, right? Means 8 element, right? 8 element, right? So right, okay, yeah, or you can say that it has 8 what 8 subset, right? Okay, because okay, I have just I've just missed one thing, right? Because in a subset we have include all the sets, right? So that means in this video I have missed just this. So okay, yeah. So apart from this, right? Apart from this 1, 2, 3, let me write this as it is. We have not included the combination of these, right? So we have to 1 and 2. This is a subset. 2 and 3. This is another subset, right? And 1 comma 3. This is another subset. Now this is the power set of, because the individual elements and the group of these elements, right? 1 2 2 3 and 1 3, taking the pair of 2 and then the whole set and the null set. So that's why you can count here 1 2 3 4 5 6 7 8. So these are the 8 right, 8 subsets, right? So that means we can say if we have two elements, then it will be 4 subsets, and for 3, when we have the 3 elements, it will have the 8 subsets, yes, or the number of elements will be 8. So let now add, right? I'm proving this, right? So now you add a new element, okay, element, let's say a is equal to 4. So to get y, means the subset, what you have to do, you have to do union operation on x union a, right? X union a. So that will be your x is 1 2 3, and then you have just added an element a, so it will be 4. So the 4 subsets, not 4 but 8 subsets, right? So 8 subsets, because we have just seen that we have 8 subsets of x, right? So 8 subset of x, right? 8 subsets of x are also subset of y, okay, because we have included this in this. So 8 subsets of x are also subset of y, right? But you get new subsets, right? New subsets, those which contain a, right? Those which contain a, right? For example, what you have to include in this set, you have to add a, 4 to that. So that will be now 1 comma 4 will a subset, right? 1 comma 2 2 comma 4 again a subset, the new subset that will be included to that, right? And then we have 3 comma 4, right? We will have 1 2 4, we have 1 3 4, right? Again we have 1 2 3 4, right? Okay, then okay, so that much, right? That these subsets will also include in that already existing. So we will have now 16 subsets, right? So that means we can prove that uh, it depends on the what we have in the number of elements. So when we have the one element, the power set of will be how many subsets? It will be 2 raised to power 1 2. When we have two elements, 1 comma 2, it will have 4, right? When we have x is equal to 1 2 3, it will have 8, right? So that means we can prove that if we have the number of elements x contains the number of elements n, then it will have 2 raised to power n subsets, and the power set, the number of elements in the power set of x will be 2 raised to power n. Okay, so it's proved, right? The proof that it is the number of elements, right? Okay, now we'll move to the another question, which is the next question is your next question is that we have a mix in arrangement, right? If there are 7 men and 5 women, and how many circular arrangements are possible in which women do not sit adjacent to each other, right? Okay. Okay, so in that case, so we have in question we have asked about that we have 7 women, oh sorry, 7 men, no? 7 men and 5 women, right? So they are saying that in a circular arrangement, right? In a circular arrangement, you have to arrange these 7 men and 5 women in a way that no 2 women sit together, right? No 2 women sit together. So for that we have to place men's first. Okay. Okay. We have to place men's first. So we have just placed the man. Now we have to place woman. So first, second, third, fourth and fifth. Okay. So in that scenario, the women are not adjacent to each other. Okay. You can place a woman here, or you can place one, because we have still 2 places step. So in a circular arrangement, we have a formula, right? That 7 men in a circular arrangement. So how many number of ways, right? Circular arrangement. So we can say that 7 men in a circular. So the number of ways in which the 7 men in circular arrangement are arranged is your 7 minus 1 factorial. So that will be 6 factorial. Okay. So number of ways is for men to be arranged in a circular manner. It will be 6 factorial, n minus 1 factorial. You know that. Okay. If you don't know that, you have to know that in a circular arrangement we have n items, and then we have to arrange them, then that will be in n minus 1 factorial ways, right? So these are the total number of ways, right, for any thing to be arranged in a circular manner, right? And then the 5 moments, right? Then the 5 moments will be your arranging, because this is the permutation, this is not the selection, this is the arrangement. So 5 moments can be arranged in out of these places, right? Out of these places, then we have 5 we have to select, okay, right? 5 we have to select, because there are total 7 places like between the mains. So 1 2 3 3 4 5 6 and 7. So these are the 7 places, right? So out of these 7 places between the two mains, we have to arrange the 5 moments. So 7p5. So calculated 7p5 will be our right, 7 factorial, then we have the 2 factorial. So for 7 factorial is your 7 into 5 into 4 into 3 into 2 factorial, and then 2 factorial, you can remove it, right, and then multiply it. So that it will be your, I think 5040, right, like something. So you can multiply 35 into 12, right? Right, this is your and this is your, because 5 factorial was 20 and 120 into 6 will be your 720. So you can multiply it, right? You can multiply those numbers. So that is be your way. So the total number of ways that can be arranged is your this 7p5 multiplied by your 6 factorial. So these are this is your answer, right? Okay, now move to the next question, right? So you have to practice these type of questions, and before your exams more and more, and so you can watch my previous videos, and I will upload more in the upcoming days, right? And on these concepts, so they have been asked again and again. So let's move to this another questions, right? This is your question number 1, and this is your E part, right? Which is in E part they have been asked about this, right? Let me see what is the question, right? So the question is your this is Boolean expressions, and the next is your f inverse if it exists, right? So let's see it what they have been asked and how. So we have already discussed this question, but I'm again solving for you, right? Okay, so we have this Boolean circuit, right? This is your this is your OR gate, this is your AND gate, right? This is your X3, okay, and this is the AND gate. Now we have again this. So this is your X2 input, this is the X3 input. So now solve it, right? So for this, let me start from here. So this is your OR gate. OR gate means your disjunction, means your plus operation. So we have X plus X2 here, right? Then we have to negate it. So X plus X2, right, negate it. You can write it, or you can write it like x1 plus x2 the complement, right? Or you can also use this symbol, right? Okay, this is the same. Now we have this x3, so here we have x3 complement, and then we have to end it. Means this is your conjunction, this is your AND gate, right? AND gate is means your dot operation. So here what we have to write here in this place, x1 plus x2 complement, then dot x3 complement, and then this is again your AND gate. So what will be write in the output of C will be x1 plus x2 complement dot x3 complement the whole complement, right? So let me further explain for you. So this is your De Morgan law, right? So you have to apply De Morgan law. I'm writing it again here, x1 plus x2, right? x2 complement, actually x1 plus x2 complement, then we have this dot, this is x3 complement, and this is your complement. So because in De Morgan's law this is A plus B complement will be your A complement dot B complement, and when we have A dot B complement, it is like A complement plus B complement. Means the plus is changed to dot, dot is plus changed to plus, means or is changed to and is changed to or, right? And the operations are changed, and then the complement here, the complement will be means on the individual elements, right? So here we have this x1 plus x2 complement, and then we have to, this is the complement, then it will be changed to the dot, dot will be changed to plus, and the x3 complement will be your x3 complement, then complement. Okay, so again we can apply the De Morgan's law here, or De Morgan's theorems, which is x1 complement plus will change to dot, and then x2 complement and complement plus x3 complement and complement. So complement and will complement negate each other, so it will be your x3, and here we have this x1 complement x2, because that 2 will be vanished, because the complement of x2 complement, right, will be x2, and then plus 3. So this is your C function, right? And please let me know in the comment box that if it is good to you, and it is helping you, and you are understanding the concepts, okay, clearly. Now move to the another questions, right? Question 1F, right? Okay. In this we have given that there is a function f r2r, right? Okay, and it is also given that this is the function fx is equal to x cube minus 2, and then they say that whether f inverse exists, whether f inverse exists or not, right? Okay, so in to prove that f inverse, so first what we have to prove that if it is bijective or not, if it is bijective or not, because if it is bijective or not, it means that it must be 1 1 and onto function, because for a function, if an inverse is exist only when if this function is 1 1 and onto, so this two conditions must be satisfied. So they ask you this type of questions more in your exams, you know. In every year and every semester they are going to ask these questions, right? So what they ask actually, if they say that the f inverse exists or not, please find, or this is that prove that it is 1 1 and on 2. They also say that this function is bijective or not. If it is bijective, then find f inverse. So there are many ways, okay, many ways they can ask these questions, okay. Now, so first of all we will prove for 1 1, right? So proof for 1 1 will be because as we know from the definition of 1 1, that means fx must be equal to fx1 will be must be equal to fx2. In subbox they have given fx is equal to fy, so it is totally true. You can also use any kind of notations, okay. So I will explain you the in both ways, right? So first denoted x1 and x2. So if these two functions are equal, and then it says that right, that it is 1. So the question is x cube, right? F x1 means x1 cube, place x1 in place of x. So x1 cube minus 2 and x2 cube minus 2. Here then the 2 will be cancelled. So x1 cube is equal to x2 cube. So we can write x1 is equal to x. So it proves that it is 1 1, okay. And in another ways we can write as fx is equal to fy. You can use any of that. If x is equal to y, then it is your right 1 1 function. So for that case we have to write x cube minus 2 and then pi cube minus 2, and the 2 will be right cancel. Then it is x cube is equal to y cube, and means x is equal to y, so we can say that it is 1. Okay, so 1 1 is this, means there must be an at least 1 is to the individual statement in x function, right? Okay, so or we can say that there must be a corresponding image or corresponding element in x to y. So that we say that it is 1. So in either of the ways you can prove. Now for onto, right? For onto what we have to prove? We have to prove if we can express this into right in y terms. So for that write it like fx is equal to y, right? Fx is equal to y. So here we have fx is equal to we have given x cube or minus 2. So that means fx is equal to y means y is equal to x cube minus 2, right? X cube minus 2, and x cube will be your y plus 2, right? Y plus 2, and x will be your y plus 2 cube, right? Okay, and okay, no, it's 3, I think, right? They have been asked for the fx cube minus 2. Okay, x cube minus 2, or it can be 3, whatever. Okay, so now for that, right, this is for x minus q minus 2, right? Okay, so that means f inverse exists, and we can represent it using this in y terms. So that means this is onto function. So if it is both, means 1 1 and onto, we can say that this is your bijective function. So this is 1 1 and onto, fx is 1 1 and onto. So this is your bijective function. Please do remember this bijective function, because sometimes they are going to ask that this function is bijective or not. So for that you have to prove that it is both 1 1 and onto, right? Okay. Now f inverse exists, so we have to find, so that means f inverse exists, so we have to find the f inverse. So to find the f inverse, what we have to do, we have to put fx is equal to y, so that will be your x minus 2, right? And then x will be your y plus 2, right? And f inverse x, right, f inverse x will be your x plus 2. So this is the f inverse, right? This is f inverse. Okay, and move to another question. Okay, question number 2a. It is your that how many words can be formed, right? How many words can be formed? How many words can be formed, right? Using the letters of the word department, right? Department, right? If each letter must be used at once, right? Must be used at once. So as you can see that in department we have this 1 2 3 4 5 6 7 8 9 10. So in total there are 10 words, right? And in the department letter, we have to look for the repetition of the word letter. So the E letter is repeated 2 times, and the T letter is repeated 2 times, and all other letters are appears only one time. So we have 8, right? We have 4 unique letters, right? So 10 words, not the 10 words exactly, but we have to write the 10 letters actually. 10 letters. So they are asking for that how many words, okay, how many words can be framed or formed using these letters that are exist in the department word. So the number of words will be, the total number of words, means 10 factorial, divided by the number of letters that are appearing in 2 or more times. So we have 2 letters at E and T, so 2 times E and 2 times this, right? And solve this and you will get your answer, right? Okay, so I'm leaving that to calculate by yourself, right? So now we have we have some other questions. The question number 2, it says that P2Q and Q, right? And prove that it is equivalent to each other. So this is very easy, right? So for that, just to remind you that these are the 2 variables. So we have how many combinations we have, true or false. It will be 2 variables, so 2 raised to power n, it will be 4 combinations. So combination will be 0 0 0 1 1 0 and 1 1. and 0, as we discussed in the first question, that 0 is false and 1 for true. So false, 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 true, true, false, true, true, right? And then find P to Q. So this is your if P then Q, and if P is false, Q is false, then it is what is it? It is true. It is false, it is true, then the whole statement is true. True false means the whole statement will be false. True true is true, right? This is your P then Q table, and then we have this P then Q table, right? So Q is your false. So we have if the P is true and Q is false, then the whole statement will be false. If P to Q is true, then Q is true, then it is true. If P that Q is false and the Q is true, Q is false, so again it will be true. And for this true will be your true, because if this is true, then this is true, and the whole statement will be true, because if P then Q, right? Okay, now find it P or Q. P or Q, your this P or Q means if one of the statement is true, then the whole statement will be true. So FF is your will be, because both are false, so false or true, it will be true, and then it will be true, and then it will be true, right? So you can see from the output of these two tables, these two are same, so we can say that, that this is true and this is equivalence, right? So hence we have proved this is true, right? Okay, so it will be like it will be a very long video if I go to solve all the questions, right? So I will make another video on the rest of the questions. So thanks for watching, and if you have any doubt regarding the questions, you can let me know, and thanks for watching. Okay.